So, well, the difference between tuple and the list is the square bracket. The tuple is a smooth parenthesis, right? And the list can also be heterogeneous. In this case, again, I have an integer, a string, another integer, and a boolean. And I have a, well, the third list is the integer. So and those are all valid or correct lists in Python. So, and this can be indexed to the first position also 0. We can also do operation on list numbers. So number L2, that's in the third position. Third position is 3, so L2 plus 1 is 4. So, in contrast to tuple, list is mutable. So we actually can do L1 equal 5. So in this case, before we have 2, 1, 3, we then assign position 1 equal 5. So not position 1 is actually the second one. So this 2, 5, 3. So list is mutable. So, well, but if you're trying to index something which is out of bound, you got this indexing error. So list is also some iterable. List we can loop over the element or items in the list. In this case, we can just, this is actually a very common practice in Python, because the range, the length of the list is what, 3. The range of 3 is actually 0 to 2. So I in that range actually go over every element in the list. So yeah, it just happens so in Python this is consistent. So range of the length of the list go over give the position of every element in that list. So it's kind of a need in a way. I mean, if you think about the range is a function indexing and they quite consistent. So it seems to be someone actually thought this through when they designed the Python language. So, okay, so, but the list can also be looped over by element. We don't have to use indexing. We can just go over the element. I think in Java, they actually gave us some special meaning of this loop operation, something I forgot what it is. As if Java thinks this is something more magical than the other one. Yeah, sorry, shouldn't say something negative about Java. This in Python, this is just a common practice too. Yeah, so, okay, for element in that list, we can just go over it. Yeah, so, hopefully that's correct. Is that correct? That seems to be correct. 2 plus 1 plus 3 is 6. Yeah, so. Okay, so and there are built-in operations we can do on the list, because list is actually a class, is the object. So in fact, if you can actually help look for the if you just say type the L. You can see the pop-up. There's a lot of methods you can use. Actually, is that all there is? Append, or maybe. Hold on. If I do a different one, there are some. Okay, this you can see the hidden one. I guess the pop-up they are all public one. Not. But let's say we'll go to Python. There's actually no difference between public and private, but they are just conventions. But the list, if you really look for all these methods, there's a lot of so-called hidden method. In fact, those are just overriding the logical operation. That's a docstring. So those are actually something you are not supposed to use directly, because those are supposed to be private. But so all the common API is the what those show up in regular names. So here we have the append, clear, copy, count, extend, indexing, insert, pop, remove, reverse, sort. So those are the, I'm going to remove that. So in Colab and Jupyter Notebook, there are some shorthand to help you go over the attribute and method of object. This is actually quite convenient. I mean, remember, there are so many functions that you don't remember all these things, but you can actually quickly look for the list of it. So I will go over some a popular method or operation on the list. So one of them is append, and then the other one is a pop. So if we append 5 is actually add to the end. If we pop, by default, it's also pop the last one. So append something, then pop something, actually nothing changed, 2 and 3. So, okay, here's another example. This time is a toList, and then we do a list plus list. What that means, that's actually just using the let me see. It's just using this override this add operation. So that's basically that plus sign is basically the add operation here. So okay, so if we toList add and then assign to the list number 3, that list 3 is what? Basically put them, concatenate them together. It's almost like a 2-string operation. You remember the string, if you add 2 string hello world, it becomes one sentence hello world, right? So, and we can also do the extend. So this is so L1 plus L2 is very similar to extend operation. So in this case, we extend the 0, 6 of the first one. You basically put 0 and 6 to the end of it. And so you, if you recall the learning pyramid, and I just tell you this, it probably is not going to hit you what it really means. You have to really, when you are doing your coding or something, you need to really figure this one out on your own and see how it works on in your own data set, right? So, and there's really not much explanation. It's just, this is basically Python syntax. It's like there's ABCD, and this why there's ABCD. It's just the way English is, right? So, yeah. Okay.
I actually had a quick question before you moved on.
But yeah.
What's the difference between extending and appending? Like they both seem to add on to the end of it. Is one inherently better than the other?
Very good. Let's look at the bottom one. Yeah, very good. So I'm going to look at the. Let you look at this one. I try to answer the question. How about that? Very good question. I'm going to pop up the. Okay, what do you think this operation will? Sorry. Let me. Okay, so that's the question. So we have append. What's the output of this? We have L1 is 2 and 3. L1 append 0, 6. And what the L1 going to look like? Again, this is really, I mean, you can argue there are some reason why this happened, but this is just Python syntax. It's like a you are, he is, I am in English. There's really not much reason why I cannot say I are or he am. It could be, I mean, in some sense, yeah. So, okay, so, oh wow, I don't think there's. Think again. You can actually try it. I mean, you can type in your own code. Yeah. So it actually look like that. So apparently, yeah. And compared to the extend at top, you see the difference there. That's what the extend does. That's what the append does. Why? Ask Python, not me. So yeah. So yeah. Okay, so this is I mean, this could be an interview question. If you go on for a job interview, good question, sorry. Yeah. Okay, so the next few exercises. A few more. This time we have a remove and delete and pop. So we have the list 2136370. That's the original one. This is actually very confusing. Let's look at the one by one to see how this compares. So original 1213370, we remove two, and then you see that's the value of 2, so the 2 is removed. And then we remove 3, which is the value of 3, so 16, yeah. But see, it only removed 1, the second 3 is still there. Basically, just remove the first one it find. So this remove 3, basically what it implies, it remove the first one it find. It didn't remove all 3. So you just have to remember this. Yeah. So and delete L1. This seems to be quite intuitive, right? So delete L1, but remember 1 is the second one. So that means 6 is deleted, right? That's correct. 1, 3. Okay, that's correct. Delete L1 is actually the second element. That's correct. Pop, that should be the last one. So 0 is removed. Yeah. So okay. To be honest, you just have to, when you really want to use, I mean, pop seems to be obvious. I think you want to really double check your code, and you don't have to remember this. And that's for exam, maybe good for you to remember. That will save your time. But in your actual coding development, you want to double check, because this is by default the list of Python. What if someone override this function, right? So if someone override the object, overload this function, it could, that's something different. So you want to always double check when you call a method of a list or an object that actually does exactly what you think it is doing. So even though by default Python list does this, you memorize this, it may not work in the specific package you are using. Am I making sense to you? Right. So for example, if you write this is the default base level Python package, the list. What if we are using a package, say, provided by your company for some customer database? And inside our database, that object, class, even though it's operating on the list of that object, it may behave different from this. What I'm trying to say is you need to really testing the code, make sure you know how it behaves, and then does it. Otherwise, it's a lot of so-called the software error will come from this. Yeah. So
when would you say it's more convenient to use like a list or versus a tuple?
If you really want things to change, you might want to use a list. Tuple, if you use a TensorFlow, you realize that in TensorFlow, many of the parameters pass by tuple. So I think the tuple is there when you want to make sure you know you are passing something as is. Right? So you don't want to pass the parameter and then somehow when you are passing between the two functions, somehow they are changed during the passing. My understanding is that tuple is best at the parameter passing. That's my own way of understanding this. Yeah. So I would think that probably a very common question on Google. So what's the when should you use tuple? When should you list? Yeah. So I can imagine there are some good so-called good practice, but there's like every rule, there are always the exceptions. Right? So, but my general understanding is I think tuple should be used for parameter passing, and list can be used for many other things. List can also be used for parameter passing. I used it before. It didn't destroy the world. So yeah. So it's besides, I don't recall Java has the tuple, and it seems to be a tuple is a Python thing compared to Java. So okay, we probably went a bit too philosophical on this. So okay, let's. Oh, we actually have about half an hour. Let's go over this, and it's so we actually can convert a string into list and back. This is actually, many of you have used this before, especially for the coding problem 1. So, and the string has some specific function, including if you look at the string, you probably can, let me see. If you s dot, there you see a lot of well, string has many more functions than the list. See, in fact, many of them I never use them. So, no. So, and if you look at the entire list, it actually so if you're looking for all of them, you can see even more, including the so-called private one. So see it's really a lot, right? Just to remember all of them, it seems to be really not a good. It's not necessary, but you should know some most popular ones. Like capitalize, that seems to be quite obvious. We capitalize the first letter, and the split, that's also seems to be quite a reasonable way. The sentence is what? I less than 3, so we split by that less than symbol. So, and we can also join this is quite convenient, especially when you want to generate output. So we can join the list, which is the list of letters and ABC, and we can join by some separate symbols, right? So AB underscore C underscore, sorry, A underscore B underscore C, right? So, yeah. The list can also have some other, here is the sorting reverse. This is actually a bit confusing again, because some of the sorted actually change the list, some of them does not. And there's really not much rational. Again, you need to, just like a technical menu, you actually need to test it before you. In fact, I personally, I don't remember. Every time I do this, I need to run it to see which one actually change, which one do not. So that's the original. Apparently, sorted does not change, but L dot sort actually change. So L dot sort changes the list itself. L dot reverse. Oh, sorry, that's a typo. There's no R there. Just reverse this. The original is also that. Okay? So the sorted. I mean, you can make a philosophical argument. You say sorted is a function. It didn't return to itself. You seem to make some reasonable philosophy behind this, but let's say this is just someone write a code. My suggestion is you always test it, make sure you know how the method behave before you actually apply it into your own data set. So, okay, here's another thing. So the list, even though we can have 2 lists with exactly the same thing, but they actually point to different objects. This is quite obvious, right? So if we change the second list, the first one is not going to change. But we also mentioned this, if we just assign a list to another variable, this actually doesn't mean anything. It basically means they belong to the same object. In fact, we did this, put this on the visualization. So this is the Python tutorial visualization tool. It's very useful, especially for this exercise. So we have 2 lists. Sorry, I shouldn't say 2 lists. We have 2 variables for list. A is 1, 2. So, okay, we have list. A is 1, 2, has 2 elements. And then we assign A to B. Wow, look at this. We assign A to B, so we have 2 variables, but both of them point to the same object. So A and B point to the same list. And of course, print A. Now, if I say B dot append 5, recall append put the element of 5 into the list. There. B dot append 5, now 5 is the last element of the list. But look at this. A is also pointing to this list. So if we print out A, it's going to also print out 1, 2, 5. So yeah, this is, you just have to keep in mind somehow Python behaves this way. So this is called alias, yeah. And then there will be, how do we clone the list? If, of course, if you just assign, it will be wrong because you just assign the same reference. Both of them point to the same object. And the one way to clone the list, we actually put the column there. Or we just use the copy method. And we actually can also recast the list. So there are probably at least 3 different ways. There must be other ways. Right. So I can even think about, you can convert, you can do a for loop append, right? Yeah. So anyhow, so the proper way to clone a list is either this indexing, copy, or casting. There are probably other ways. Yeah. So and the mutate. So mutate and iteration on the list is also has some tricky issues. And because the list can be iterated using the item, and then you should not operate on the list when you are mutated. Otherwise, in this example, we try to remove the redundant list element, but because the list itself is also mutating, so actually it's not correct. Remember last time I asked a student to do a demo, a student had the for loop, but inside the for loop is also changing the looping variable. So this is very similar to that. It's always, that is the practice you should avoid. When you are looping over a list, you should not change the list inside the loop. That means you are working on a moving target. And it's not a good idea to, at least in programming science, to work on the moving target in a looping operation. Okay, so the correct way to actually, well, at least one way to looping over the list is clone it first. Well, that's of course it's pretty dumb if you think of it, because if you're working on the say the telephone book, are you going to really copy paste the entire list? So that's actually, it seems to be a very dumb approach, but it's actually, if you really want to looping over the item, you should copy that list, then looping over. Of course, the better way is actually using the range operation. You are not changing the list, you're just looking at the reference of the position. Right? Instead of using this item looping, you just go over the indexing. That's probably the other better way to do it.